Hello students, let's look at the next session. So in this session we are going to see a statement that is find out whether the sample signal that is x delta of t completely represents x of t. So in short we need to check whether the spectrum of x delta of t matches with x of t. So x of t means it is the analog signal and we multiply it with the s of t, then actually we are getting x delta of t. This is what the expression earlier we have seen for x delta of t. It is summation x of nts into delta of t minus nts. So when we take the Fourier transform on both sides for this expression, by applying this particular mathematical expression, that is f of t minus t0, Fourier transform will be what? F of j omega into e raised to minus j omega t0. So by applying this particular theorem, or rather the expression, x delta of t will be written like x delta of f is equal to summation n is equal to minus infinity to infinity x of nts into e raised to minus j 2 pi fn ts. After applying this particular statement, now from the equation 2, if you just able to recall the equation 2, that equation 2 is regarding x delta of f fs, that is for n equal to 0, plus summation fs x times minus nfs when n is not equal to 0. This is what the equation 2. From this equation 2, we are able to write it like x delta of f. Again the same thing. Here specifically we need to concentrate on this part and be neglected due to minus w less than equal to fs or frequency less than equal to w. This particular portion, this can be neglected since it is not bounded within the range minus w to plus w. So that is what we just need to concentrate spectrum around n equal to 0. So this is what n equal to 0 part. So we are just concentrating on it. So x delta of f will result in a simple equation, that is fs times x of f. Now if it is fs times x of f, let's find out the x of f is equal to what? 1 upon fs x delta of f. Now after putting the value of x delta of f in the equation, it will be 1 upon fs summation x of nts e raised to minus j by fnts. Recall the expression of Fourier transform of f of t minus t0. So this is what particular expression. After simplifying this equation, we can further write it like 1 upon fs can be written as 1 upon sw, because this fs will be replaced by w, which is shown by or verified by the sampling theorem in time domain. Then only we can say that the signal can be reconstructed from its sampled form. Means from x delta of t, we can recall the x of t only when fs is equal to twice w or it must be greater than twice w. So fs is equal to twice w over here. So if fs is twice w, obviously ts will be what? 1 upon 2w. So that is what written over here. So ts is replaced by 1 upon 2w. Same is the case here. So ts replaced by 1 upon 2w. This is what the expression, we can say this is nothing but the equation number 4. Now this equation is obviously valid for frequency minus w to plus w. Now from this one we can just easily conclude that spectrum of x of t is same as spectrum of x delta of t in frequency range, which one? Minus w to plus w. Hence, sample signal represents original signal x of t successfully. So this is also the part of signal recovery, where someone can predict whether the from the sample signal we can able to recover or reconstruct rather x of t. Yes, this can be done surely. So thank you everyone. This is all about the verification of x delta of t with respect to x of t. In the next session, we are going to look for approach called as a recovery of an analog signals. So in case of the recovery, we are totally concentrating on equation number 4 itself. Thank you everyone.